Okay, so we're doing a lot of the basics. So unit one's about points, lines, planes, and angles. And part one is on points, lines, and planes. We're also going to do part two today on segments, rays, and distance. So unit one, part one, essential questions. How do we define points, lines, planes, and space? How do we properly label these geometric objects? What does it mean for points to be collinear and non-collinear, or coplanar and non-coplanar? How can we find intersections of these geometric objects? Okay, so let's go and get started. So first off, what is a point? I think it's pretty obvious, just like a dot. It's like X, Y, and Z are points. So you can just write as like X, Y, or Z. That's all. They have no dimensions, just a very simple thing. Um, and usually label with capital letters, just so you know. Label with capital letters. Okay, line. What is a line? So line is a set of all points. So a line has an infinite set of points and extends forever in both directions. It's one dimensional. It has an infinite number of points. So for example, right now, this line here, let's say D, I think it's a D, D, E, and N. That's 3 points, but are there other points? Sure. Like there's a point where my finger's pointing. And that's point right here, right there, right there, right there. It's all over the place, right? So there's an infinite set of points. So the way you can label it, you can call it line K because there's a little letter right next to it. So you call it line K if you want. You can also call it DE or EN or ND. There's so many ways you can call it. The bottom line, no pun intended. You guys get that? Ah, James got it. Good job. Good job. Stump dad joke. Anyway, and they're organic, by the way. That wasn't planned. Um, so here's the deal. You pick 2 points, right? Just pick any 2 points, and it doesn't matter. Like I could have done like DN. I could call that in any order, doesn't matter. But the bottom line is just want to just pick 2 points, right? Just pick 2 points and just draw the little arrows. That's it. So very simple. Okay, a plane. So plane's two-dimensional. It's a flat surface made up of infinite points. There's a bunch of dots here, like dot, 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 and so forth. You could also think like this too. Has a bunch of lines. Line, 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 line. But it's like a piece of paper. So this is a plane, right? That's a plane. It's like very flat, right? Um, so what could I call this? Well, you see there are letters next to each of those planes. So I call it plane X or plane Y because there's two different planes there, right? So plane X, plane Y. Um, or if you wanted to label the corners, you could label them like this. You call it plane ABCD. So again, should be pretty straightforward. You guys have seen this before. I hope you guys did graphing in your middle school. And we know what we call this. Yeah, coordinate plane. Yeah. And it's a plane because it's two dimensions, right? Perfect. Coordinate plane. Or an XY plane, right? Okay, 3 dimensions. We'll worry more about that in the spring semester. But like a cube or a box or a room, those are all examples of 3 dimensions. Like this room here is 3 dimensional, right? Um, there's a box up there, right? Or this is 3 dimensionals, like a cylinder, right? So yeah, that's just, but we're not going to spend too much time on that today. Um, okay, any questions so far? Yeah, totally very, very basic stuff, very basic. Gets a little more interesting. So, all right, so next up. collinear and non-collinear. Um, so pretty obvious, collinear means linear means line, co means same. So on the same line, right? Like if you have co-captain, you have two captains who are on the same team, right? Co-pilots, two pilots who fly the same airplane, right? So co just means points in the same line. So for example, X, Y, and Z are collinear. Now, non-collinear are points not in the same line. So let's say I drew a random dot, call it A. So X, A, Y are not collinear, right? Because they're not on the same line. So what this begs the question, what would always guarantee a collinear relationship? As long as you have 2 points. Sorry if you're gonna say that, yeah. But with three or more, then all bets are off, right? We're not really sure. Now, coplanar are points on the same plane. So for example, I could say like S, is that an S? Yeah. S, K, and L. Those are all on the same plane. Or P, U, G. Yeah. Those are all on the same plane. But then you have to be a little careful. Like would P, U, S, and K, like how can I, that's kind of weird, right? Because these are on the same plane, but then P's somewhere else. I can't really like get a piece of paper and get all four of those points on that piece of paper. It's just impossible to do that. So those are not coplanar. So this begs a question like with collinear, how many points do you need to guarantee a coplanar relationship? If we need two to guarantee a collinearity, how many do I need to guarantee a coplanar? Actually, don't four. Well, four we would guarantee we would not get it, but at least three. If you have three, then any 3 points are always in the same point, right? But four would then guarantee would not be right. Okay, cool. So now we have that said. So let's now test your knowledge. So I'm going to give my voice a little bit of a break. And I'm going to have you kind of work with the Elbow partners because I can't talk the whole time. It gets kind of boring. You guys should definitely be more active. So go and try example one, talk to each other, check with each other. I'll give you guys maybe 3 or 4 minutes. I'm going to do it too, but I'm going to freeze my screen so you guys can't see my answers. I'll reveal in a few minutes. Well, plus I also have the answer key in front of me too. But yeah, we're going to check to see your understanding of what's going on.
This one has, I don't know about.
Oh, wait, I'm. You have to. Yes.
You got like figures. I don't think it's depending on what's in there. Yeah, we could have like the same birthday. Well, pretty sure on the birthday was like the false.
If it lies inside.
No. Oh, maybe. I think that's false. Oh,
Do you do example 2 also?
I'm gonna show the answers. Okay, let's go over right now. All right, so here's what I got. Okay, so you guys working great. Love the work ethic here. So yeah, B, C's and M, 100%. Plan M contains A, B. Yep. Oh, sorry, false. B is false. A, B is not in plan M. Line L intersects line AB at point B. Line L is over here, intersects actually at point A. So that's false.
Yeah.
D, A, B, and DA intersect at point they do. 80 is in plane M, it is not. Plane M intersects almost like AE at point B. It sure does. AE intersects plane M at point B. It sure does. AB are collinear, they are. That's just, you got lucky there. BFD are collinear, they are not. Just the way it's set up. ECFG have to be coplanar. We got a little lucky there as well. 4 points isn't necessarily guaranteed coplanar, but in this case they are. So okay. So any questions? All right, well, let's keep on moving. All right, so I will do example 2 of the guys. Okay, what's going on with example 2? So you got a 3-dimensional object. It's like a box, right? Name 3 lines that intersect at point G. So here's point G, right? So I could draw this line. What would you call that line? Good. I would agree. Okay, what if I drew that line? What do you call that one? FG. Yep. Remember, you gotta do the right symbols. And what if I drew that one? CG. Yep. By the way, I could get a little more creative. I could have drawn one diagonally from A to G if I wanted to. Could have done that. Sure. Yeah. Ooh, I like that one. Yeah. So a lot of different options, right? But those are 3 that make sense. Okay, name 2 planes. Let me erase stuff by the diagram. Name 2 planes whose intersection is FB. So FB is, it's kind of like the crease in that box, right? And what 2 flaps, or not flaps, but like what 2 faces part of that crease? James, go ahead.
EAFBF.
The front. And what else?
And then the FBC.
On the right. Yep. So if I shade, I'm going to call that FGCB. And usually, you realize, there's not a special symbol. Wait, go ahead. Yeah. 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 Make sure you put it in the proper order. See, I wouldn't say FBGC because then you're kind of zigzagging. You go FBGC, like you want to go kind of like clockwise or counterclockwise. So FBCG or FGCB, or you can start with any letter, doesn't really matter. So in this case, I'll call it I don't know, I'll call it FBCG. FBCG. And plain. And by the way, my handwriting is not the greatest, so if you have a hard time reading my handwriting, I'm not offended, just let me know. The other one we'll call EFBA. Cool. Okay. Speaking of which, we just talked about EFBA. EFBA is up front. EHGF is up top. So let's do a little erasing here. Okay, so you have this, right? So you have this, and you have this. So clearly, what line did it have in common? Yeah, yep. So it requires a little bit of three-dimensional perspective. So again, the one in front is EFBA. One on top is EFGH. Yeah, and that's it in touch. So, yep, cool. In two planes that do not intersect, well, basically planes are parallel, like kind of like that. Um, Kyle, right? Yeah. So what do you think, Kyle?
ABCD and
Mhm.
then HGFB.
So top and bottom. Yeah, I like it. So you're saying, and I'm getting sick and tired of writing the word plane again, so I'll just put the four letters A, B, C, D, and E, F, G, H. Cool. Now our points D, H, G, and C. Ooh, that's a good one. So D, let's get my D, H, G. Well, of course, yes. Well, yeah, of course. How about D, H, G, and F? Yes or no? Can you get all that in one plane? It's kind of weird, right? No, we can't. You get HGF or DHF or DHG, but yeah, that's not gonna all fit on a plane. So do E and F make sense? Parts E and F, we're okay with that? Cool. All right. Next one's a cool one. I like this one a lot. So remember, it's all about getting it like on a piece of paper, right? It's like A, B, G, and H. Yeah, because like what if I had a box or like a tank or an aquarium? I could totally take a piece of cardboard or a piece of paper and lie it diagonally, kind of like that, and touch it. It's all good. That wouldn't be a problem at all. Yeah, so that's a yes. All right, let's keep on moving. Okay, this stuff should be review, hopefully. Hopefully. Slopes. You guys know how to find slope? Rise or run? Okay. You did place in this class, so and I know we asked on the placement test, so hopefully you guys okay there. Um, why don't you guys go ahead and try yeah, so go and try to find the slopes of those three. What do you notice about them? And then figure out what you would say for part C, and then write an equation. Um, what does equation line contain the points? Okay. So go and try example three. I'll show you my answers in a moment. Yeah, we're doing so far. All right. What do you guys notice about these lines? Or all slopes are the same. So what does that mean about the 3 points? Collinear, good. That's how you prove it. And then I'll show you the equation in a moment. Let's take flip. So I'm going to cheat and just show you the answer key. Yeah, so if you find the slopes, and plus this is the previous teacher's handwriting, which is much nicer than mine. So KM, for obviously negative 1/2, get negative 1/2, negative 1/2. So whenever that happens, it has to be part of the same line, right? How else would that happen? So they have the same slopes, the linear. And then how you write the equation line, my preference, by the way, is you express equation lines in point slope form. Just kind of the habit of that. Because I mean, I know you guys are 3 years away from taking a calculus course, because next year you do algebra or algebra 2 trade honors, maybe pre-calculus, then you'll do calculus, right? And that's a norm that we tend to write the equations that way. So just get a habit of that. I mean, if you want to write it in slope intercept form, y equals mx plus b. I mean, it's good to know that too and how to interpret it, but I prefer you write it that way. So if you already have your slope, then you can use any of the 3 points provided as x1 and y1. Remember, it's y minus y1 equals n times x minus x1. So any of those are valid. If you did write slope intercept form, it's fine. I think you would have had y equals negative 1/2 x plus 7.5, if I'm not mistaken. So yeah, okay. All right, let's keep on moving. Okay, this is a really good check on algebra. Make sure your algebra skills are strong. You have 2 lines. You want to find the intersection. You want to verify algebraically. First of all, let's just graph it. Graphing should be pretty straightforward, right? Y equals 2x plus 7. You have 7 here, up 2/1. And let's see, go down over here. Okay, because I'm cool like that, I could do these straight lines. Next up, 4y. Oh, no, I'm not cool anymore. All right. 4y equals negative x minus 8. Y equals negative 1/4 x minus 2. Let's go different colors for contrast. We go lime green. Down 1, right 4. And up 1, 1, 2, 3. I don't think I did the best job drawing that red line. I'm gonna fix that red line. It's kind of bugging me a little bit. Yeah, I feel a little better now. Okay. I'm gonna freehand this one. So where does it look like they touch? Yeah. Now you can always plug in negative 4, negative 1 back into each equation to see if it makes sense, which it will. You could do that. So it does satisfy both equations. But the verify algebraically, you remember the algebraic processes for solving systems? What are some of the processes you can use? There's several, by the way. James, go ahead. That's one. How about another one? Go ahead, Dan. Not Dan, sorry. Sorry, let me get your name right. No, this is Daniel, right? Yeah. No, not Daniel. No, sorry. Sorry. Hold on. I'm gonna get these names right now. This is I gotta work on this. What am I? Hold on. Ishan. Ishan. Sorry. Yes, Ishan. Yes. Yeah. So you could substitution or elimination, right? Those all could work. There are even other techniques too that you'll learn down the road. But yeah. So what if I did substitution, right? If y equals 2x plus 7, let me just substitute into the equation, right? So you should get 9x plus 28. 9x equals negative 36. X equals negative 4. If x is negative 4, what does y equal? Negative 1. So, okay. Oof, that was quite a bit too. There's like a challenge thing on the. Let's come back to that later. We have time because I do want to make sure we get to the next step. For some reason, my notes doesn't. Wait, hold on. Can I guys? It didn't make the photocopy. That's okay. There's like a challenge problem, but you say it for another time. It's all good. All right, so we're on set two. And so how are we doing on time? Okay. Yeah, you're all right. Okay. But I'm gonna try to go a little faster. So, okay. Okay, so we got this stuff, right? So we're doing segments raised. Let's see, one, two, three. I don't know. We'll see. We'll see. All right. Okay. So anyhow, a segment. Now, a segment is not exactly a line. But we'll get to that in a moment. First off, let's say y is in between points x and z. Then therefore y lies on xe. So for example, like let's say like x here and z here, and I connected those two. And to say it's in between means it lies on the line. So between this implies that points x, y, and z are collinear. Now, there's between a segment and array. So a segment has two endpoints. Array has just one endpoint. So for example, xz would look like this. It clearly has an infinite set of points, but it ends in both places. Ray xz looks like this. Whereas an arrow, so it goes forever in one direction. Forever towards z. And again, a segment's not a line. Don't call it that. You call it line segment if you want, but it's not a line because it doesn't go on forever. So you have lines, you have rays, and you have segments. Opposite rays. The rays with a common endpoint that form a straight line. So it could look like this, for example. Say it calls like A, and that's C. So rays, actually, let me do the symbol instead. AC and AB are opposite rays.
Would that be a line?
Yeah. Yep. That's a good observation. Also form line CB. 100%. Okay, the word postulate. Do you know what that word means? Postulate, has anyone heard that before? It's basically a statement that's you always assume to be true. That's it. So a statement always assumed to be true. So we don't question it. There's no way to prove it, just the sky's blue. I don't know. Athens in California. Hey, I don't know. It's just always true. So a math statement that is assumed to be true. Example, 2 points, determine the line. Why? Because just does, right? Just does. Let's keep on moving. Distance is just basically a length of some sort of segment, right? So every point can be paired with a number on a number line. We know this. How you find the length of a segment on a number line? Phrase rule that always works. So you could just say, I'll just type it up for you guys again. Find difference between coordinates, then take absolute value, guarantee a positive outcome. You guys remember what absolute value means, right? Yeah, like absolute -5 is 5 or absolute -4 is 4. So yeah, let's find a difference and take the absolute value. That's it. So like JL, how far is J from L? 5. That's it. Yeah. I mean, you could do -3 minus 2. Which is -5, but I'm going to do the absolute value just to be on the safe side. So you get 5, right? Or KM, 4. Yeah. Or in this case, it's kind of funky. You don't point P is not really anywhere, nor is point Q, but if you want to find PQ, just doing this. Or you could write like this. They're both valid. An important notational difference too. If you see that this is the segment symbol, the J, which Y? Yeah, it's a J. Yeah. No worries. Um, yeah, so this indicates a line segment. When there's no symbol, it indicates a distance or length. Yeah, so that's what's happened there. So I'm not too picky about that, but if you were to see two letters and you don't see a symbol above, the implication is you gotta find the distance. That's the implication. If you do see a symbol, then it just means, hey, you're just talking about the physical line segment. That's it. So I'm not too picky on that. Don't worry about so much about that. Ruler postulate, that's kind of a dumb one. But points can be paired with real numbers on number line, of course. The distance between the 2 points are the absolute value. Fine. This one I do care about. Segment addition postulate. I like to brew as SAP. And we're going to be doing proofs down the line. Um, it's pretty obvious. I mean, if I drew points A and C, right? Well, wouldn't AB plus BC equal length of AC? Obviously, right? But this will play a role, and some other stuff we'll do down the road. So yeah, but that's good to know. Congruent. Congruent means equal, or more specifically, same size and shape. We use that term a lot as well. Same size and shape. So we would write like this. Um, AB. And it's like a equal sign, the tilde sign up above. So you totally could write like that. Sometimes you use little symbols, these little markings to show congruent as well. And again, congruent segments are segments with the same length. Of course, they have the same shape. I mean, well, yeah, they're line segments. Segments with equal length. Okay, we're good. Okay, let's keep going. Midpoint. Midpoint's halfway through. So this would be the same as this would be the same as this. Let me do a little better. There we go. So essentially AX, where X is halfway between them. Um, X is the midpoint of segment AB. And a bisector is aim to cut something in half. So say I call this like line CD. Then CD is the segment bisector of AB. So just cut something in half. That's all. Okay, so why don't you guys try the next two examples? Give my voice a little break. Um, and then we'll be able to wrap things up after that. So go and try examples 1 and 2. And talk to each other, work with each other on this, and I'll show the answers in a moment.
So A is a so.
Yeah.
Insurance. Ladies.
Gonna show you some answers right now. All right. So answers totally vary, by the way. Totally vary here. So like you have two names for a line. Yeah. Call it JK, KL, LM, JM, whatever, or not MJ, like Mike Jordan. I don't care. But you gotta use that double arrows, right? Segments, you do the same thing you did for A, just don't do the arrows. That's all. C, again, you do the same thing you did for A and B, just do one arrow. And you could do whatever you want. But two pair of observers have to be a little more mindful about that. So like LJ and LM, because they have to have the same endings, right? They got to start at the same place, just go opposite directions, right? By the way, if I said this is just for fun. Are those different? They're not different. They're the same. Why are they the same? They have the same endpoint, right? Are they going the same direction? Yep. They include the same thing. Isn't K going to be part of this? And of course, K is part of this, and the things right before K are part of both. So just something to think about. If I ask you to name two distinct rays, that will not count because those are the same. Those are distinct because they have different endpoints and have them going different sections as well. So, okay. Something good to think about. Some true false stuff. C is not between A and B, duh. But CB is the same as BC. Yeah, who cares? Tomato, tomato. Doesn't really matter, right? AD, AG are opposite rays. Yep. CBBC is the same. They're not the same rays because they have different endpoints. Lines, again, tomato, tomato, doesn't matter. But F's not the same because one's a segment, one's a line. Now, they both have infinite set of points, but this has more. Going forever in both directions. That's a little more combined, right? Those are the same, sure, why not? JF, MCD, they both goes forever in both directions. BA and BD. We talked this already, so that's kind of that's a good way for me to have some foresight there, right? Yeah. So okay. Let's move. Okay, we do need to keep moving here. So we're at the home stretch. Let's see. Okay, example 3. Okay, this is more algebra. Actually, you know what? I want you guys to do this also. I think you guys can handle this. Do example 3. The example B, part B is really good. This is one of my favorite problems. That is totally gonna be a test question, by the way. Part B. Maybe want to star that. Hmm? Correct. Yeah. What do you mean by line? Just like
This.
yeah, but no arrows. Right, no arrows. Yeah, I love part B. It's one of my favorite questions. So you're doing some algebra. The algebra is pretty easy for A, a little more complex for part B. And you got to check your work as well. So I think A is pretty straightforward, right? X plus 4 plus X equals 14, right? Made it this far, you guys should be okay with your algebra. X is 5. You have 9 and 5 for this, and then, yep, easy peasy. Of course, yeah, good, yeah. Okay, B helps to draw. So you got J, you got L, and you got K somewhere in between, right? And the whole enchilada is 12. Making me hungry right now. What do we have for lunch today? By the way, our lunches are good at school, by the way. We do a good job lunches. I think the teacher's lunch is a little bit better. Okay, kale's 3x, right? So what are you going to do? You're going to do segment addition postulate, right? Because doesn't JK plus KL equal JL, right? And x squared plus 3x minus 18 equals 0. So x plus 6, x minus 3. Actually, I'll give one hard on this. This one's a little too easy. But I like it because then you have to verify your work. Sometimes both answers could work. Sometimes one, sometimes neither could work. There'd be no solution. And don't think the positive answer is going to be valid. Is the positive answer valid here? No. Well, actually, wait. No. Hold on. It is. It is. I lied. It is. I lied. It is valid. It is valid. -6 is not valid. My apologies. Yes. What did my Ansky was telling me? Ah, this and -6 is not valid. Sorry. I was looking at my Ansky wrong. Yeah. Okay, cool. So 3, right. So question on that one. All right. Then example 4. Um, using an line below, answer the following questions. Find the midpoint of AE. Well, how long is AE?
Eight.
It's 8, right? Yeah. So the midpoint has to be 1, correct? Just halfway between. In the diagram above, AC and CE are the same, and B is a midpoint. Okay. So CD is 2 and AB is 3. By the way, B is a midpoint of AC. How long is BC, guys? And if this is 6, and this has to also be 6, how long is DE?
Oh, wait.
4, right? Yeah. So done, 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 right? Okay. Really the home stretch. All right. You guys been troopers, by the way. You guys been awesome. I think I'm still at 75%, so I might be able to last today. All right, example 5. Suppose that points A, R, and V are collinear. Fine. AR is 7, RV is 5. Fine. Then which point cannot possibly lie between the other two? Okay. So AR, I think this is okay, right? Nothing wrong with that. I'm okay with that, right? That makes sense. Um, what if AR was the longest segment? Or actually, let's say we do it like this. No, yeah, we could do it like this. What if AR is the longest segment? And that's V. That's fine. Yeah. But can A be between R and V? Probably not, right? Like we'll say I drew RV, which is 5. Well, that's gonna be weird then because Yeah, A would be over here then, wouldn't be in between, right? So A is the one that can't be between. Yeah, that's only, or you put it to the left, which we already did. So just kind of get you thinking a little bit. Um, in example 6, given that B is midpoint of AC, C is midpoint of BD, what can you conclude? Okay. So I'm gonna be hypothetical. Well, not really. I don't want to feel like being hypothetical. So we know that's gonna be true. Like B is halfway between A and C, C is between halfway between B and D, right? So what's true about A, B, and C, D? They're congruent, yeah. So A, B is congruent to C, D. A, C, and B, D, are those the same? Yeah, 100%. Yeah, I think Kyle. And lastly, AC and CD, are those the same? Not necessarily, but you could say AC is twice CD. And I'm not going to do any congruent symbols, so I'm just going to do like distances. Or half of AC is CD. So, yeah, cool. Whew. All right. You guys can definitely put a pretty good net homework if you are not all mapped out. If you need a little break, I don't blame you. If you want to put your head down for a little bit, uh, all good. Or maybe you just feel like you want to do something for English class. But this is a good opportunity to knock out a good portion of the homework. Um, so homework is going to be this part here. So you got like number 1 and number 2 and 3, 4 and 5 and 6, 7, 8, 9, 10. Was that? So here's yeah, great question. I never grade homework for accuracy. Yes. Yeah, I never grade homework for accuracy. I just don't have the time for that. You guys saw I have 3 little kids. I do a lot of other stuff in my life. But yeah, 1 to 10. Yeah, just finish the rest. And then after that, you'll see the answer key. So you have the answer key to check your work. I always like to provide that. So great question. So what I'm gonna have you guys do um, is upload it to Schoology, but hold off on that for now. For now, just do it. Show it to me on Thursday, and then I assume you guys keep your cell phones in your backpacks. Okay. I'll have you guys take your phones out because, if with my permission, you can take your phones out and we're going to work on, or you can use an iPad. That's fine. Then I'll just like kind of demonstrate. You can try it at home. But what we'll do is we'll practice uploading the work. And if you can't do it in class or you don't have a phone here, you can do it with your parents' phone or whatever it is later in the week. But for now, don't worry about submitting the homework. Just do it. When we meet Thursday, we'll talk about like what I'll do is I'll like to take someone's homework. I'll get my phone out and I'll upload it. And then I'm going to go into your account and I'm going to show the process on what I know. Because I think it's good for you to model it first. Because you guys are freshmen, you guys still kind of making sense of everything here. So don't worry about that. But yeah, just do it. I'm not gonna have any quizzes this week either. Usually I like to do homework quizzes, but again, we're just kind of getting the swing of things. So for now, let's just keep moving to the lessons and the homework. I think that makes most sense. So, and ask questions, and you guys can get good portions done today. Let me stop my recording.
What? I will do lesson.
11:35. I always put the schedule up because the schedule is confusing. Um, we actually, hold on, stop recording.